Hello and welcome back to another Common Lisp tutorial. In this video we're going to complement the Python video with a Tic Tac Toe game in Common Lisp. We're going to build it up piece by piece, and we are going to use the ouch, excuse me, well I have to adjust, I damaged my knee, and it's painful to sit in the same position for too long, so you will hear the chair creak as I have to just move my leg around a bit. Anyway, we'll be building this up piece by piece, and we will start with a game function, then we'll display the board and so on, and we'll build upon each function and use that to complete the entire game. So let's get started. We will define a game. All it will do is return 0, and let's compile that. Let's open the REPL on the right. On the right, although something I failed to do. I'm not even in the right project yet, so I'm going to decompile this. Yeah, let's get rid of that. What I want to do is show you some of the tooling, because I'm not going to leave the text editor while we build this entire game, which if you're used to languages like JavaScript or Python, you might be used to going to a terminal. And although I've got a REPL here on the right hand side, it's not a terminal, and I don't have it open all the time. So I won't be running npm or anything like that. I won't even be opening sbcl directly. It's already been done for me just by virtue of opening this file. So I'm going to quick load this thing called CL project. And you can see ASDF there, loading it and bring it in, which is great. So we would do CL project, make project, and then we're going to pass in a path, and those begin with #p, and then we give it a string, quick Lisp, local projects, Tic Tac Toe 2. I'm going to evaluate that, and you see on the right hand side that it's written this project. So we're going to open that file now. Tic Tac Toe 2, source main, there we go. And we're going to repeat what we did, but we're going to do it in the right place this time. So we've compiled that and we've run it. So we got a 0 back, so let's put something into the REPL. We've recompiled that, we've run it, we've got hello world pop up, so that's great. So let's start building this piece by piece. In a previous video we looked at the concept of key arguments, and they are optional arguments to a function, and you define what they can be. So if the user calling your function provides one, it's that value, otherwise we use the default one. And I quite like just being able to call game as is and it give me a default set of parameters. So the first thing we're going to do is have it give us a board parameter. And unlike the Python video where we had a grid being nested lists, it's not necessarily the case here. Common Lisp has the ability to build multi-dimensional arrays with the makeArray function. And you give it the dimensions, which in our case are going to be 3 by 3, and we pass it an initial element of a dash, and that is our function. So let's recompile that. We're just going to run the game. And you can see here on the right hand side that we've got this #2a, and we've got our 3 elements inside a list, and 3 elements inside a list, and so on, inside a list of its own. So this is what we would expect, but we don't want it to look like that. We want a function for printing out the board in a nice, easy to read way. And we're going to do that. And we're going to be using a mixture of recursion in places, but we're also going to start looking at some of Common Lisp's loop structures. Unlike, say, Scheme, which is another dialect of Lisp, but it's not Common Lisp. Scheme tends to avoid loops almost altogether and use recursion almost exclusively, whereas Common Lisp has a lot of looping constructs. I just happen to come from a functional background, and so I tend to think in terms of recursion. So I'm going to try and get out of that habit, and I'm going to try and embrace some of the looping structures that Common Lisp gives us. And we're going to look at one of those in this function, and it's going to be called the do times macro. And this is built on top of a simpler macro, I believe, called do, which we will be using later. But this is as simple as it looks. We do something n times, and that n is bound to a symbol. So we're going to do this thing 3 times, and x is going to represent the n in this case. And it's the same with y. We're going to do y 3 times, and y is going to represent the number of the iteration number we're in right now. And because we're displaying a list, we're displaying a grid, sorry, we want to know, we want to do one thing if we're at the end of a row, like print a new line, and something else if we're not at the end of the row. So we're going to do an if, and this is going to be equal y and 2, and we're going to do format t. So this it's very simple. We just have a nested loop, and we just check to see if we're at the end of a row, and if so, we just print out the value and an end of line character, which is the tilde %sign. But if we're not, we print the value, a space, a line, and a space for the next value to be picked up. Aref is a new function you won't have seen before. Ow, my leg. And aref looks into a array that is constructed here, and you get the parameters based on the dimensionality of the array. So if this was 3 by 3 by 3, we would need an x, y, and a z. So x looks into the first thing, and y looks into the list within the element within that list. So this gets the first list, that gets the value within the list. So that's all aref does. Now we're going to compile this, and we're going to get rid of this, and we're going to say display list. Display list, display board. What am I talking about? A display list. There we go. So we're now able to print our grid in a way that we could recognize as a grid. And we have our first function here. The next thing we're going to do is try and write values into that. So we're going to update the board. And we're going to do things slightly differently to the way it was done in the Python video, if you saw that. Instead of passing x and y around directly, we're going to pass around a value that represents a coordinate system. And that's going to be what's called a property list. And we're going to unpack bits of a property list in this function, but you're not going to see a property list until a little bit later. So don't worry if you see something unusual in this function. We'll talk about it, we'll go through it, and when we plug it in, when we're testing it in just a few moments, then it'll make sense. So in Common Lisp, we have a function called setf. Its complement is getf, and this is like set field and get field. So objects can have what is loosely classed as a field. I mean, in Common Lisp we have classes, we've got structures, we've got associative lists, property lists. There's a lots of things. Hell, we have just variables in the global namespace. Well, not the global namespace, the variable namespace. And setf can be used to change the value of any of these things, and it's a nice unified interface. I've seen similar things in Python where you define objects to have magic methods, and they behave similarly when you call common functions, but those are functions operating on objects, and because in Python everything is an object. It's slightly different in Common Lisp, where you can take or leave the object system entirely, and setf operates on things even more fundamentally simple than objects, including lists themselves. So when we use setf, we have to use it in terms of getf or a function like that. So we call setf, and if you have a look in the bottom there, it just takes rest and args. So what setf does is it takes like a pointer to something, and what we're doing here with aref baud x and y, although this returns a value, it represents a position in an object. And so here, where we're formatting that, it resolves that and says, well, just get me the value pointed at here. Whereas setf, we use exactly the same thing. We use aref, although you don't always have to use aref. It's just in this particular use case that we're using aref. Yep, that looks about right. And so, because I said we're going to be passing in a coords object that represents x and y, we need to use setf's complement, getf, and I'm just going to split this over a few lines so it's a little bit easier for you to see what's going on here. Setf takes a pointer, or a position in an object, be that a class, a structure, a list, in our case an array, and sets the field to be player. And we're doing something similar here, although we're using aref to get a value out of board, we're also using getf to get a value out of the coordinate system, and we're using getf to get another value out of the coordinates object. So you can see these play an important part, these getf or these f suffixed functions. So that's interesting. That's what they're doing. I certainly find it very interesting to think in terms of setting a pointer to a field to be a property. I guess it goes back to like languages such as C that deal with pointers a hell of a lot more often than JavaScript or Python, but it's still interesting, and I kind of like that. But if you've never seen those before, it may take you a little bit of time to get used to it, but there we go. I'm gonna just get my indentation a little bit easier for you. So with that in place, we are going to compile that, make sure that's in the system. We're going to update the board. We're going to pass in board, and this is the property list that I told you about. Let me just save the file. it looks a little bit like a dictionary or a hash map where we have a key followed by a value and a key followed by a value. It's not a dictionary, but it can behave a little bit like one. So we update the board. We in the top left, the 0, 0 position, we're going to put next, and then we're going to display that board there. So we run this function, and there we go. We've updated the position, we've printed it out, and you can see this new representation of the board state. So this function now works. We've plugged that in, we've got it working. The next logical thing that we'll want to do is define a valid position p function. And what this is going to do is this is going to return true or false if the value looked up by the aref function is equal to a dash, which is our initial element. That is to say, if the position in the object is this, then we can write to it's valid. So we're going to say equal dash, and we're going to say aref board, and we're going to do that getf coords x and getf coords y again. Let's compile that, and I'm going to format t . Okay, that's good. I'm going to copy that here so we can see what's going on. It should say t and then nil. So if we compile that and run the function, it is called with one argument but wants two. Valid. We haven't passed in board here. There we go. Yeah, it's recompiled that without any issues. So we're going to run that now. So the first test was t. That is a valid position, 0, 0, to try and write value to. So we're going to update the board with the 0, 0 position of an x. We're going to display the board, and then we're going to see if it's still valid, and it says nil. So after placing a value there, valid position p returns false, which is exactly what we wanted to do. When we're talking about p-lists, property lists, getf uses the keyword :x to get 0, and getf :y to get 0 there. So that's how this getf complements a property list here, and you know, that's what I was talking about when we said we'll see how this works later. There's a little bit more to it when variables get involved, because we're actually using values here, and we'll want to we'll have to look at how to interpolate values into a property list, but that's when we get onto the turn functions. It's nothing too crazy, it'll just look a little unusual at first. However, there's 6 utility functions, 2 of which are player turns, 1 of which is game over, and we've already written the other 3, so you're really going to see how we build up property lists pretty much now, to be honest. Now the first of the 2 player functions, the CPU turn, is the easier of the 2 to write, so we will simply write that, and we're going to start a let star block, and we're going to have x equal random, and this is going to be array dimensions, array dimension board 0, and we're going to make random state t. We're going to set the y to be random array dimension board 0. Yep. make random state t, and this is why we need to let star. We need to actually build up the property list interpolating x and y, and this is going to look a bit weird, so I do apologize, but this is how it has to be. There you are. This backtick is what is saying we're going to start interpolating values, and the comma before a symbol here, because remember that x is a symbol that we're binding a value to, the comma symbol says look up the value this symbol represents and put it in the list. Because Common Lisp, we can put symbols directly into lists, so I could easily have done this, and it would have just given me colon x, x colon y. Why it wouldn't have looked up, you know, let's assume there is a x and y variable in scope, which can do here, you know, x, let x1, y2, and I'm just going to do this, x, x, y, y. Yeah, you see it says it's defined but it's never used. So what we have to do is we have to use the backtick with the comma prefix. I'll show you that again, but with actual values. Colon x, comma x, colon y, comma y. And there you go. That's how we interpolate the values. So that's why we have to use this. The backtick says, well, you know what? I'm curious. Hey, what's it doing there? Right, okay, so let's put that there. For some reason it doesn't want me to be able to put a comma there. I wonder if that's to do with the backtick. Yeah, it is. So it will not let me put a oh yeah, that should have been colon x, comma x here. So let's just try that in my text editor. Right, that's that. Colon x is x and colon y is y. I'm expecting this to fail. Yeah, so the comma has to be inside a backtick. So let's set that back to what it is. And let's retry. I don't think that'll work, it won't. But if we do that now, we get that. So it has to be within a backtick. That's just the way it works. And that's all this is just allowing variable interpolation. So anyway, let's jump into our let star block now that we're able to represent our coordinates as a property list. We're just going to do a quick check. If valid position P, board coords, then we return coords. Otherwise, we return the result of CPU turn with the board. So we'll recurse. There we go. That is the CPU turn. Now, the player turn isn't that much more difficult, but it is slightly more involved. It's only 12 lines. It's not a massive amount of code. Sorry, I was just counting there. But it is more than, you know, the CPU turn. Yeah, it's like twice the length. Anyway. There we go. We're just going to start by asking the player to enter an X position. Then we're going to try and bind X to what the player enters. Now, what I'm typing is very important. I'll show you what that does just now. So parse integer takes a number as a string and tries to convert it into a numeric number. And this is all fine and well until somebody puts like just letters in there, at which point we get an error. Let's abort out of that because I'm not trying to solve that. What we can do, however, is pass in a key argument called junk allowed and make sure we set that to t. When we evaluate this now, if we have something that doesn't evaluate directly to a number, it just returns nil. And that is perfectly fine for our use cases, because if we're reading something in from the user, they might be deliberately trying to enter something wrong, or they just might have hit a letter under a number. So we're not going to punish them for that. We're just going to say, let them put in whatever they want, try and turn it into a string. If you can't, just assume the value is nil. Now, irrespective of whatever we have, even if it's nil, we're just going to see unless is basically like an if not, but a one clause if not. So we're going to take whatever the user's entered and stored in the symbol x. But if x, whatever x contains, is not in the list 0, 1 or 2, we are going to recurse. And we're going to start again. Now that is one clause if they've entered something in the x that is wrong. We then have to have a nested let here, and we're going to do the same thing, but for the y position, and it's basically going to be exactly the same. We're going to parse integer, we're going to do read line, we're going to do junk allowed with t, and we're going to do exactly the same. We're going to do unless member, and this time it's y, not x, is 0, 1 or 2. We're going to do player turn, and we're going to pass in the board. Now, we have x and y. What we're going to do is we're going to create yet another let block, and this is going to be the chords, and we're going to do the value interpolation here. 1, 2, 3. So we've got our let block. We're going to do if valid position p, board chords. Then we're going to return chords. Otherwise, we're going to return the result of calling player turn with the board recursively. And that is our player function. So we're going to test these two. I've just compiled them and made sure that we've got them in there. So we're going to get rid of that. We're going to get rid of this. CPU turn board. And we're going to print this. Format t, and we're going to copy this and paste that in there. So you can see now that we've run this, and we've got our x is 0, y is 1. So we're just going to run that again and prove that we're getting random numbers. Yeah, there we go. It's a little bit predictable. There's only 9 numbers it can choose from, I suppose. Well, 3 numbers it can choose from. So it will be quite limited, and we do already have a value in one of them. So we can see that works. Let's check the player turn function. So it's going to ask me for something. It's asking me for input down here because I executed the game function here rather than over here, but it's printed out x, so let's put in 1 and 0. Again, it asked me down there, but that's fine. So I put 1 and 0, so it's built up my property list, my chords, based on the information that I entered. So we now have the 2 player turn functions. We're about halfway through it. We're about to hit the biggest function of all in this program. Same with what we were doing in the previous Python videos. This function has 10 ways it can exit, so it's quite a complex function to get right. And I'm pretty sure there are better ways of doing something like this, and I'm going to put a shout out to the community. I'm not entirely convinced what I'm doing here is the most effective way of doing it, so if you can see what I'm doing and you know a better way, please correct me. But what I was learning is we want to use this equal function to compare that if three things are equal to one another, and I could not find a function, a built-in Lisp function that would facilitate checking more than two things at once. So I have resolved to using and building up large lists of things we want to compare, which doesn't look particularly elegant, and I think there must be a better way. I just couldn't find it. All that being said, what we're going to do is build the game over p function, which is going to return true if the game is over or false if it's not. And we're going to go through the permutations of all the ways this can succeed or fail, and we need to test that. So it takes a board and that's it. And in the previous Common Lisp video, we got introduced to this concept of flet. And I'm going to create a function called drawP, which is a predicate that's going to find out if the game is at a draw. And we're basically going to copy a lot of what we did from the display board function. We're just going to traverse across it, and if there is a dash in any of them, we're going to say that this is not a draw, because there's still spaces that players can use. So we're going to let counter be 0. Then we're going to use our do times macro again with x is 3. And we're going to do times again with y is 3. Then we're going to say when equal, we're going to use the dash symbol. Aref again, board x and y, because this is how we get an object out of a multi-dimensional array. We're just simply going to increment counter, and then we're going to close all of that and stay in our let block, because we are going to return 0 equaling counter. So if that is true, then the game is at a draw. If it is false, however, the game is not at a draw, and we need to determine what other victory conditions there are. Now, because there are 10 ways, as I mentioned, to exit this function, we need to use a cond. There's no other way around it, and under normal circumstances, this function will return nil. There are 9 very specific circumstances under which a victory can happen, otherwise the game is not over. So T0 is our sort of end clause of seeing what's going on, our end clause of defaulting to just assuming the game is not over unless we found a way otherwise. So we need to check our rows. Our columns, our rows, our columns, and our diagonals. And we're going to do that. We're going to start with the first thing. I'm going to say and equal aref board 0, 0 and aref board 0, 1. And honestly, I got tired of having this all on one line, so I'm going to split this up. It got really hard to see. So 0, 0 and aref board 0, 2. And then we have a third clause that we want to check. We want to check and not equal aref 0, 0 there we go, and that is going to return t. 1, 2, 3. It's going to return t. And there we go. So we're going to say and this equal to those two, and that equal to those two, and this is not equal those two. We're going to return t. Now, I'm going to condense it all down because the only thing that really changes is the numbers. And I'm going to get rid of the REPL for now so we can have the room to see what we're doing. The next thing we want to do is exactly the same. We're just going to change the numbers in the grid. There we go. What is the final one? Is 1 and 2, and this is going to be 1 and 0. We're going to copy this a third time, and the third set of numbers is 2, 0. Then it's going to be 2, 1. Then it is 2, 0 again. So we're checking the first one again against 2, 2. And that is going to be 2, 0 at the end there. I'm going to compile that. And we are going to get rid of this. There we go. So I'm going to compile that. I'm going to bring up the REPL. And let's have a look. Let's get rid of that. And I'm going to invoke the game function. I have an error. Because board needs to go here. That's my bad. So I'm going to recompile that function, and I'm going to say retry, because the function works now. This is the joy of the Common Lisp debugging experience. You hit an error, you can jump into the debugger, you can fix your functions, you can say don't bail out, don't crash, just retry once I've fixed it, and it just works, and that's super nice. So we can see here that the game over is indeed true because there are 3 X's in a row there. So let's change this to the next row and test that this works, which it does. So we're going to move along and we're going to update these to 2, which also works, which is great. So we're going to copy these 3 lines. And we need to alter the numbers. So in this one, checking my notes, we start in the top left corner again, but instead of going to 0, 1, we go to 1, 0, and then again it's 0, 0. Then we go to 2, 0, I believe is where we're going with this. Yes, that's correct. And at the end of the line it is 0, 0. The second set of columns would be 0, 1, and this would be 0, 2. This would be 1, 1, and this would be 1, 2. Looking at this would be 0, 1, and this would be 0, 2, and finally this is 2, 1 and 2, 2 there. At the end of the line we want this to be not 1, 0 but 0, 1, and not 2, 0 but 0, 2. So let's set this all to the same thing. Let's have a look. That's great. So this wants to be 1 and 2, and this wants to be 0 and 0. So we have a line straight down the middle, and it's not done what I thought it should do. So let's have a look. I bet I've not recompiled that function. So I've just recompiled it now. Let's rerun game. There we go. So we know that this line now works. Let's move this along to 1. Now recompile that. And that works also. Setting this to 2. Saving it, compiling it. That is also true. We've done all rows, we've done all columns, so we only need 2 more, well 3 more, but we need our diagonals, and I'm going to copy that. And we start at 0, 0, we move through 0, 1, and we end up in 2, 2. And at the end of the line we check 0, 0. Then instead of 0, 0, we start with 0, 2. We go through 1, 1 again, through the center. Then instead of 0, 2, we check 2, 0. And instead of, that would be 0, 2, then 2, 0, and then not 0, 2. Yeah, I'm just checking my assertions there. So I've recompiled that function. We're going to start with 0, 0, 1, 1, and then through to 2, 2. So we've recompiled that. We have true. We start in the top left and move down into the bottom right. So let's set that to be 0, 2, and we're going to change that to 0. So we'll recompile that, and we will run game. So we go from the bottom left up to the top right, and that says it's true. The next thing we want to do is we want to do our draw p function with board, and we're going to return true. So I now need to populate the entire board with patterns that don't mean anything. So I'm going to put right, I'm going to put x in a 0, 0. That looks right. I'm going to put an O in 1, 0. I'm going to put an O in 1, 2. Then I'm going to put an, I said O, not X. Then I'm going to put an O somewhere else in 0, 1. Then I'm going to put an X. Frankly, it doesn't matter where, because there is no way to win that looking at it. So this goes in 2, 1, and 2, 2. There we go. It says the game is over because no one was able to form a victory condition. So that draw T is now plugged in and working. So that's everything for the utility functions. All we really need to do now is build up our game loop, and it's 12 lines. It's not a lot of code at all, and we're going to explore some new things. We're going to have a look at the raw do macro, or a representation of it, and we're going to use that, and we're not going to recurse through our game loop like we have in previous videos. We're going to use the do macro and loop infinitely using that. The first thing we want to do though is we want to set up a turn counter, and this is going to randomize which player gets to go first on any given iteration of the game. There we go. Then we're going to go and type do. Now, do takes a few things. The first thing it takes is an expression to evaluate every time the loop loops. But you'd use this for like updating a number or something like that. But we're not tracking our state that way, so we're not going to put anything there. But you still have to have the empty parentheses. The next thing is what variable are we using to track how to break out of this loop? Well, we're not using a variable, we're using a function. So we've got these parentheses, so we need to call our function, game over pboard, and that's why there's two sets of parentheses there. Is typically it would expect an expression, but because we're calling a function, that evaluates to the result, so that's why the double parentheses. The inside one is a function call, and the outer one is basically where we're storing the result of an expression. So that's what that is. And we get into the do loop body now. So here we go. We're going to display the board as a matter of course. Then we're going to check to see if the turn counter is even. And then run a certain player function, and if it's not, we're going to run the other player function. So if, and Common Lisp has this thing called even p, which is useful, turn counter. So if the turn counter is even, we're going to create a let block. We're going to say chords. There we go, and we're going to just update the board with the chords and an X. And for the computer, whoops. There we go, 1, 2, 3. And we're outside of the if. We then want to increment the turn counter. Then the game is basically over at this point. So we're going to say display board. Then we're going to say format t game over. I'm going to compile that, make sure there's no warnings, save that, and I'm just going to make sure my parentheses match up to where I think they should. Yeah, that matches up there. We can even, where are we? That's the let. Oh, right, yeah, no. That doesn't happen there. Let's get rid of display board. That. There we go. Yeah, there we go. Sorry, I got confused with my parentheses there. So let's compile that, and I'm going to jump into the REPL here, and I'm going to run game. Not game over p, game. So it's asking me if I want to go first. I'm going to take the top left square. Computer takes center. I'm going to take bottom right. So I'm going to take the top right, and then the middle last. The game's over, and I've won. I blocked the computer. Let's see if we can get the computer to win. it is just randomly picking. There's no intelligence to it, so it might take a couple of attempts. It might stupidly not do anything. Oh, the REPL is got a bit stuck. No matter. Just reboot the process. That's fine. That's why we have these tools. I just need to recompile the functions. That's not a problem. I'm just going to insert them. It's the player turn. We want to our game over function, our game function, and we're just going to do this again. So the CPU went first this time because it's printed out the board here, and then it's printed out the board with a position in it, so we know the CPU went first. So I'm still going to take the top left square, but I'm going to try and, you know, force the computer to win. Yeah, the computer won. Sorry, I didn't see it. It got the diagonal. That's good. I'm going to try and force it into a draw now. So I'm going to take the top center square. Computer takes that one. I am going to take the far right square. Oh, the REPL got itself confused again. Although it certainly beats restarting the editor when you can just restart the REPL from within your code editor. It is certainly very useful. So the computer went first. I'm going to take the top center. I'm going to take the it's a draw I'm trying to force it into, so I'm going to block it. Oh crap, I entered the wrong coordinates. Crap. 1, 2. Yeah, well, right. We'll force it into a draw again. Okay, there's no possible way to win here now, so that's great. So I'm going to take the bottom. There we go. It's a draw. Nobody won. Those are the 3 ways. I won. Computer won. It's a draw. So that's it. That is a Tic Tac Toe game in Common Lisp. I appreciate this video has probably gone on a lot longer than I would normally have wanted, but genuinely this is as fast as I can get through the material without it being too fast, I think. So I hope that was interesting. If you liked it, please give me a thumbs up, share it, subscribe. I'm going to be putting out more videos next week. I hope you, your friends and family are safe during the pandemic, and if you haven't heard from someone in a while, maybe give them a call. Take care everyone, and I'll see you in the next video.